We have an equation this time that we need to go through and solve, and when we're done we do need to check our solutions. There's a few ways to approach this problem. With the problems that we just did where we were simplifying rational functions, it makes sense for us to tackle it the same way. So over here on the left side I see I have a rational function. I'm going to factor the top and the bottom. I need to do that because we have some subtraction there. So in my first step, I'm going to factor that x squared minus 5. I'm sorry, x squared minus 25. That is a difference of squares pattern, so that does factor into an x plus 5 times an x minus 5. The bottom of that fraction is not factorable. I'm just going to put it in parentheses because the subtraction there to remind myself. The only way I can cancel is if I have a matching x minus 5 in parentheses on the top and the bottom. That gives me then an x plus 5 over 1, or just an x plus 5 equals 14. Subtracting 5 on both sides gives us a possible answer. Here's why I say possible. There are times when we're solving equations when you can introduce extraneous solutions into the problem. One of those times is if you cancel something out on the top and the bottom of a fraction that has a variable in it, like we did here. So as soon as I saw this step, I knew we were going to need to plug this back in at the end. The answer is either going to be 9 or else this is not going to work and we're not going to have any solutions at all. So I do need to plug that back in, but there is a reminder at the top of the problem also that I need to go through and check my work. So I'm going to check and see if x really is equal to 9. I'm going to take 9 and plug that in for all the x's in the original problem. There we go. So plugging in our 9, we have 9 squared minus 25, which is 81, minus 25, that's 56. And 9 minus 5 on the bottom is 4. So 56 divided by 4, that is 14. So I end up with 14 equals 14. That is definitely a true statement. So that does verify that x is equal to 9. And that is our final answer in that problem. For letter B here, we have something similar. We have a rational function on the left side of our equal sign equal to our number 7. I'm going to go through and factor the top and bottom of that rational function. In the top, I have 3 terms. I'm going to use that add multiply method, looking for 2 numbers that add to be 3, multiply to be a negative 10. Those 2 numbers are a positive 5 and a negative 2. I can use the shortcut because I have a 1 in front of the x squared, so x plus 5x minus 2 is how that top would factor. The bottom does not factor at all. I do have a matching x minus 2 on the top and the bottom, so those will cancel. That will give me, just on the top, an x plus 5. And over on the right side, a 7. We have a 1 on the bottom here, so it's really an x plus 5 over 1, or just an x plus 5. And if we subtract 5 on both sides, we get our final possible answer, which is 2. I say possible because we did cancel on the top and the bottom of that fraction something with a variable, so this may be actually an extraneous solution and not be a solution at all. So I do need to check by plugging that in. So we would have 2 squared minus 3 times 2 minus 10 over 2 minus 2. 2 squared is 4. 3 times 2 is 6. So 4 minus 6 is negative 2, minus 10 is a negative 12, and 2 minus 2 is 0. But you can't divide by 0. That gives you an error. So that means that 2 is not a solution. This is not a true statement. Something that's undefined can't equal 7. So the only possible algebraic answer we came up with was 2, but that does not work. When that happens and you don't have any solutions left, that means we have no solutions.